And these are kind of tough. And this is, and we're gonna do a test, a paper and pencil test over this. Whoops. So, we gotta make sure we understand all this. So we're starting with, go to click and close to have a look. You might remember, this is a couple days, going back a couple days ago, we were looking at this rational function. First step is always, we wanna figure out what the domain is. And we're all good with that, so we're gonna factor the bottom, factor the top. We had unique zeros of the bottom, which gave us vertical asymptotes, which showed up on our table like that, right? We were able to take limits, at infinity to get the horizontal asymptotes. In this case, we know we have a rational function where the degree of the denominator is higher than the degree of the numerator. So if I look at the ratio of the leading coefficient or leading terms, if I take that limit as x goes to plus or minus infinity, the bottom is, I'm going to get 1 over x, right? So the bottom is going to go to infinity, the top doesn't. So I get 0, and that shows up on our table like this. The limit at infinity is 0. The limit at negative infinity is 0. And we already see then that we've got these 3 asymptotes that are going to guide our sketch, right? Now we got to just fill in the blanks with the other stuff. Okay, and so what did we do? We took a derivative, simplified it, and we found that the derivative was nowhere undefined in our domain, right? It was negative. What did we do here? So we took the derivative and we wanted to find the zeros of the top, right? The zeros of the bottom are already our asymptotes. Those aren't going to be critical numbers. Oh, that's what this is all about. That's right. So it's nowhere undefined in our domain because the places where it's undefined, those are already places where the function doesn't exist, right? So if they're not in the domain, they cannot be critical numbers. Then we wanted to find the critical numbers where our derivative is 0. Well, that's the rational function is 0 when the numerator is 0. So we set the top equal to 0 and solve. And right away we can see that our discriminant is negative. So we get no real solutions to this equation. There are no real zeros at the top. So we get no critical numbers for the first derivative. Then we were just in the process of taking the second derivative when our all too short period ended and we didn't get to finish this up, right? So we had gotten here. I think we had executed the quotient rule for our second derivative, and now we just needed to simplify. Okay, so this is good practice. What can we do to simplify?
You're going to take out an x squared minus x minus 30.
Okay, good. Look, I see like bases here, don't I? Right. I've got a base to the 1 and a base to the 2, so I can factor out one of those, power of 1. So we can take out this guy. And then what are we left with? From the first term, in the first term, yeah, we're going to get one of those left over, right? If we factor one out, times negative 2x plus 6 minus, so there's our minus sign separating the terms. This one's going to go away completely, right? Yeah. So that we took one of those, that one goes away completely, so then we end up with x squared plus 6x minus 33 times 2x minus 1.
Oh, you forgot the 2.
You got,
So,
yeah.
Oh, there's a 2 there.
And there's an exponent on
And
the
the
first.
first term is x squared minus x. In the first.
Very first.
Oh, over here, there,
Yeah.
yep, good, thanks. Okay, and then all this is over x squared minus x minus 30 to the 4th. So what else could we do? Okay, good. Now I can cancel these because this is a factor of the top, isn't it? It's
Yeah.
being exclusively multiplied by everything else on the top. So we can do this and just make that a 3, right? Okay, so then on the top now, unfortunately, here's where the fun ends. Now we've gotta, well, okay, I guess one other thing we could do, you see anything else we could factor out of the top? There's just one little thing that'll help a little bit. There's just one other little tiny thing that we could do, just to make our lives a little bit easier. We could take a 2 out, couldn't we, right? So I could break this up into 2 times 3 minus x, right? And then I could factor a 2 out front also. Right, and just factor that out front. Okay, it just makes things a little easier. So now, what do we got? I'm gonna have to go to the page, let's get to it.
Why does it always make it a little bit bigger?
I don't know. I think I know why. It's because I always make these pages the size of this page. I got the dimensions. I do a custom page size in Promethean, so it fits the same aspect ratio as a sheet of paper. So if you ever wanted to print these out, like in the distant past when I didn't make them black.
ink.
Yeah, it'd be a lot of black ink. You're right. But it would. So in the past, when I first started doing this, and I thought people might want to print PDFs, but they never, why would you? Really? I mean, it's all online anyway. Why waste paper? It's all there. But I've just never quit doing that. That's why. It's kind of a pain. But I do like to be able to go down a little bit, so the page isn't so small. Okay, so now we could multiply some things out, right?
Mhm.
So we've got 2 times on the top, if I distribute. I'm going to distribute this times this. So that's going to give me what? If I distribute my negative x first, how about I'm going to get a negative x cubed minus plus x squared plus 30x. If I distribute the 3, I'm going to get a plus 3x squared minus 3x minus 90.
I see
Right.
what you did there. I like that.
I
I've
did
never
too.
seen that before.
I just thought of that. That was kind of cool, huh?
I
Minus,
appreciate that.
minus, what do I get over here? Now, let's go ahead and distribute this. We got to really do some mental gymnastics. We're going to distribute the negative and the 2x minus 1. So we're going to get minus
3x.
2x cubed minus 12x squared minus, plus, you're right, 66x.
No, it'd be plus.
Plus.
Because I got this minus out there that's changing the sign.
Plus x squared.
Plus x squared
That's so good. 6x.
plus
I
6x
like that so much.
minus
That makes
33.
life so much easier.
Okay, all divided by the bottom.
Guess they're not falling over here, but it's how they do it.
And then, so now if we just combine like terms, what's that gonna give us? So, and let's see if we can do, man, let's be really tricky here and see if we can combine like terms from everything all at once. Because when they're lined up vertically like that, we can do it. So we get negative x cubed minus 2x cubed. We get 4x squared minus 11x squared is negative 7x squared.
Yeah.
Correct.
We get 27x plus 72x is 99x.
Uh-huh.
And we get, did I do that? Yeah, I did. Okay, so negative 90 minus, so negative 123. Okay. Okay, so That's our second derivative. That's inconvenient. Why is that one kind of inconvenient?
So there's a lot of terms.
It's a lot of terms,
And you can't.
and
It's hard to
it's
back.
cubic, right? So there is no cubic formula. So we gotta make a decision here. Let's just talk about how we could solve this, and maybe not actually do it. Maybe we'll cheat and use technology, but how could we? How could we analytically get the zeros in this thing?
There's the grouping method, which might or might not work.
Oh, yeah.
Probably not.
Probably not.
Well, one thing you always do wanna check is you wanna see if the ratio, it's not gonna work, never mind.
No.
You wanna see, one thing you could check here? We could see if the ratio of -3 to -7 is the same as 99 to -123. It's obviously not. If it is, you could factor this by grouping, right? But we can't. So then, if we were gonna do this analytically, we would wanna use the rational root theorem, right? We'd wanna find all the factors, the possible zeros of this thing would be ratios built from the factors of the constant divided by the factors of the leading coefficient.
Uh-huh.
So this would be a mess, right? We'd get all the factors of 123, positive and negative, divided by the factors of 3. Which, and factors of 3 are just 1 and 3. But I'm gonna have to find all the factors of 123. Wonder if this one actually works out.
Because then
I'll
you do
let you
synthetic
do that.
division.
Right, and then you do synthetic division. Right. Here, let's cheat and see if this works, and if it does, I'll remind you how to do that. Somebody just graph that on your calculator or in Desmos or something. Here, I'll just do it, I guess. I've got Desmos right here.
He's got Desmos right there.
So.
Are you recording?
I am recording, yes.
That's a responsibility on yourself.
That's your job.
It's your job. You were appointed.
Your job is not my responsibility.
Yes, it'd be nice if I got some support from my
Well,
family.
because Ryder and the tax are missing.
Need help.
So what we're gonna do is I'm gonna throw these for spring and stuff, so summertime, but in the winter, they're all the time that I have right now, that was gonna be corroded.
It's all the best.
Get screwed up, I don't care.
The presso is travel.
Okay, oh man, so we don't get anything good. We get weird zeros. Okay, so here's what we get if we cheat and use Desmos. And let's go ahead and make the, so that's what we get, right? We get zeros. Those are our zeros.
Nice, look nice.
Mm-hmm. Well, they're not integers.
It's all about rounding.
Yeah.
Right, but if they had been integers, or at least fractions, and those are not, those don't look like
Is there
fractions.
a way to make,
Or 79.
And you hit fraction.
yeah.
No, unfortunately, you can't do it in here, which is too bad, yeah.
Everything else.
Desmos was good up until this point.
Yeah,
I like-
no,
I
Desmos
don't
is
like about Desmos.
You could.
very disappointing on this
I see,
one.
like, points and, like, exact, you guys put Desmos, it really is-
Let's be honest, the state
like,
senate probably runs
multiply,
on Desmos.
if you use it in, like, rounded numbers and stuff.
Desmos?
Yeah, just give me.
Wait,
Is there a way to do that, Mr. Rivett?
What's that?
So like, when you do like a point like that, like let's say it's like a number with pi, in
Mhm.
Desmos it always does that as like a decimal like that rounded. Is
No,
there
I think I figured out a way, I'll show you that. I think I figured out a way to do that.
Yay.
So, well, don't get too excited, because I got kind of a partially good answer for you on this one. I don't think it's exactly what you're looking for, but you mean this, right? Like, so what if we wanted to make a new function here? What if I want to do, this isn't so great. But if I go, let's get rid of this dumb thing. If I go into here on the x-axis and I go from like 2 times pi over to, or negative 2 times pi. It's still going to give me decimals for the points on the curve. But
But
at
don't
least
you
this
need
is
to
kind
go-
of nice. I can go to 2 times pi. And if I do my steps in something like pi divided by 2. That's kind of cool. At least you get pi's on the axes, but I think if I go to a point here, oh, it does, look at that. That's pretty cool.
Yeah, I always just thought if you put it in the
That's-
steps in terms of pi, then it gave you it in pi.
Say it again.
If you made the steps like in terms of pi, then it gave
Well, I
you
think
the
it,
point
no, I
in
think it
terms
would,
of pi.
like if I did cosine, I think it still will.
Square root.
Watch, I'll show you. Like if I do cosine, oops. See, it's still gonna give me, like if I go down here, it still
Yeah.
gives me pi,
Yeah,
right?
Well, that's not like a square root.
Yeah, I wonder, so what if we did square root
Yeah,
of,
'cause that's the other thing, you get like a really, if you really want square root, it just gives you a decimal. So
Like
you
square
need
root
an
Yeah.
exact-
2 over
But you need an
2.
exact number for.
it wouldn't be, so this works pretty well for trig stuff because pi is predictable, but the problem with square roots is which square root are you gonna write it in terms of? Let's just try it though, I'm kinda curious. Like if I did, what's something that's gonna give me, like what if I did, okay, let's make a new one. So if I do h of x equals x squared, 2 minus x squared. And if I go in here and I write my, let's go from like -3 times square root of 2 to 3 times square root of 2. This might work, we'll see.
no.
Not gonna do it. No, doesn't do it. So that one won't do it. It's still just, see, that should be negative square root of 2, but, no. But the pi one does, that's kinda cool.
It's really square root. So,
Yeah, I wish they would, now, just if you had TI 89, it'll do it for you. I know, the TI 89 is pretty cool.
What's the
It is.
latest model of the TI?
$80.
Yeah. It's
What's-
down to 80 now, it used to be a lot more than that.
What's the latest model of TI?
They make the Inspire, but I hate the Inspire. It's so hard to use, I can never, it's like,
It's not very inspiring.
it's not very inspiring. I like the 89. I'm kind of old school. The 89 is a great one to get though. If you're, I hate to even tell you this, but if you're going to go into like physics or, I mean, you might even want to think about selling your 84 on eBay after you take SATs and all that stuff because you need it for the SATs. But once you get into college, the 89 is pretty slick.
I'm gonna keep my 84. I wanna be.
Well, there are like MathCAD and Maple, and there are programs that do that stuff.
Except when the Air Force TI work.
Okay, so in our domain, what was our domain again? Everything except
5
So-
and 6,
Five,
negative
six, or
5 and
negative five.
6.
-5 and 6. So all of these numbers we would have to add to our table then, right? Let's just round them to like one place. So -7.5, 1.5, 3.6. Somebody write those down.
7.5, 1.5, 3.6.
Right, so those are zeros, and we'll even cheat and use this graph of the second derivative. I can't believe this one worked out so hard. I thought I kind of thought this was gonna be a little better where it was gonna be something that, and it's not. Hope we didn't make a mistake. Huh. Maybe not. Well, at the end, we'll graph this thing and see if we did it right. I'm not,
Okay.
so if we go over to our table then, we gotta add those critical numbers. So what were those again?
Negative 7.5.
Negative 7.5 is a zero of the second derivative.
And 1.5. And
3.6.
Okay. And so then we'd have to pick test points. I wanna make a copy of, so here's, boy, that's horrible, second derivative. So here's our second derivative. Let's make a copy of this. We'll put everything on our table page so we have it all in one place. Oh. What did I do? What? Oh. I hit new page, I guess.
What? Yeah, right.
What?
I feel like the fingers.
Fever, I don't have fever. What? Dude, actually, that was funny. I took my temperature to see if I had a fever. I had 95 degree. Oh, 96. It's 95 for a second. I think it was 96. It's not bad. It just means I don't have fever, which means technically I don't have corona, because I don't have the same as corona. People get that.
Whoa, so are you
That was the weirdest. But we need a fever, cough, and then trouble breathing.
Do you really need to breathe in, like, you get like such a low, that
just kill the man?
it's just like the fever.
What are you putting in against
And
it?
you just kind of carry
Well, that's
it.
your-
I don't know, I just looked at what the CDC said, and they said fever, shortness of breath, and coughing. They said the fever and shortness of breath were the most concerning, coughing's just there. And then even if we got corona, we'd be completely fine. And no one under 30 is dying from corona in the US, right?
In the US.
Yeah.
If my sister got coronavirus, she would die.
Yeah, probably.
They showed that all infants that got corona survived because of saying the fingers were warm.
Yeah.
All the people that died just
Her
heard
sister had like major heart problems.
Yeah.
Okay, so then we'd have to, we'd wanna test the test points around this, right?
Yeah.
Let's just cheat and use our graph. So if we pick a point, just to make this a little faster, so if we pick a point, this is a graph of the second derivative, right?
Well,
Actually, it's not.
it's the top.
It's only the top, yeah, so let's go ahead and,
I graphed the second derivative and it's not critical.
it's what?
There's the second. I have the second derivative. I typed it all in there.
Oh, that's what it looks like, okay, so it's
Yeah.
asymptotic, yeah, it would be asymptotic.
Yeah.
Okay. So I'm gonna show you another trick. Why not? Show you another trick here. So if we want to evaluate, you guys know this trick, but if I want to use Desmos to kind of help me out here, I could, and I wouldn't even have to have the fancy graphing version of Desmos. I could just use the scientific version of Desmos for this.
So maybe they told me you won't.
So if I put in, I'm gonna graph, I need to make this bigger. Oh, man.
Say the first knowledge.
So I'm gonna set up a function for the second derivative.
How'd you do that?
I just highlighted it and hit parentheses.
Come on, man. I'm learning some tricks.
Again, this class isn't actually for kids, it's for 3 people.
So you just multiplied it all out?
Well, no, I would just always click on the little keyboard thing and then.
I've actually been working on this, I used to always go,
How do you put X on faster
but you were in
than
the.
androgen?
I said I was always like run with it because I would never, like, I didn't know the carrot thing was an option, so whenever we do something, I would just go back, so skewed. I could not figure out
That's
how to
lit.
do it. So, like, move here.
I do remember in
And then
like
you can go
6th
back
grade, just
and change
multiply
it.
like 3 to.
Okay, so we could just pick some test values, like something below negative 7.5, like negative 10. All I have to do then is just go f of negative 10, and I get a positive answer, right?
Yep.
Okay, so we'll just cheat a little bit.
Again,
So
like,
f
it's
of
like crazy, it's like-
negative 10 is positive. Let's try,
6.
yeah, negative 6.
Yes.
8.
Negative 6 is negative, okay? So we go, negative, what's another point we pick then?
0.
0 would work, yeah.
And it's.
And 0 is easy to do. We don't even need our fancy calculator for 0. At 0, we're gonna get, on the top, we're gonna get negative, aren't we?
Yes.
and on the bottom, we're gonna get negative, so it's positive.
Yes.
Jim and I finished that yesterday.
And then like 2,
Yes.
That one's negative.
Because we're just adding.
Then you go to speech.
2 is negative,
We finished it, it's really much. No, but they said we don't do it.
4 is positive.
4 is positive.
Yeah.
So if we test 4, it's positive. And then we actually do probably wanna check one over here.
And
How come?
7, because it's on its own.
It's behavior.
Ah, okay, good. And we wanna work as far down the table as we can, so if we pick a number like 10, what do we get?
Pause,
Pause.
I don't know.
Negative,
Negative, okay?
but
So that's all we really need then, isn't it? So we get an inflection point there, we get an inflection point there, and we get an inflection point there. And if the concavity is negative, and these are my asymptotes, what does it have to do over here? There's only one thing it can do. There's no other features of this thing, no extrema.
that has to
It's gonna have to be down here, isn't it? Right, it's gonna have to be there.
be negative.
You tell me, I could fill in this line without even, just from the picture, what is the slope gonna have to be there?
Positive.
Yeah, it'd have to be, wouldn't it? Okay. So then, we get no extrema on this thing.
Mhm.
If we pick a couple, like at 1.5, if we plugged 1.5 into our function, to just get an idea where this is. Not that we need to, but if we did, just so I could anchor the point. If I plug that into my original function, there's my original function. Somebody just plug that in and see what you get. If I plug in 1.5, I'm gonna get negative 1.5 on the top.
You did like 2.9 equals the negative bit,
So I'm getting about 0,
pretty much.
pretty
yeah.
close to 0, right? Roughly 0. It's gonna be a small positive number, so I'm just gonna do this. I'm gonna say at 1.5, we get something like 0 plus, right? So we get a point right there-ish. And that's gonna be where we're transitioning from positive concavity to negative concavity, and it's an inflection point. So what's it gonna look like?
Um,
Wait.
It's like a puzzle, isn't it?
Yeah,
Okay.
it has to come down.
It's gonna have to come down from this axis, from positive infinity, and it's gonna have to transition to negative infinity there. Is it a horizontal tangent line?
Oh,
No.
No. There were no zeros of the first derivative, were there? So when we draw this, we wanna draw it where it never actually gets horizontal, it's just gonna do something like.
Isn't there a horizontal asymptote?
Yeah.
So it
Okay,
can't-
yes, okay, but where does and so the question is, how can we pass through that if it's a horizontal asymptote? It's no big deal.
There's
You
a
can
hole.
pass through a horizontal asymptote an infinite number of times. All it does is guide the behavior at the ends of the function, right? And remind me, I'll show you an example of an infinite number of times in just a second when we're done with this. Does that make sense?
Yeah.
Okay. So then what about over here? We've got negative 7.5. If I plug that into our function, what are we gonna get? We just need an estimate.
How do we have an inflection point if it's not horizontal?
You can't, all an inflection point means is a transition of concavity.
Because it transitions again in between those two,
Yeah,
so that's not.
it's not.
Right, now these are not inflection points because there's no tangent lines there.
No, but in between the asymptote, there's.
Oh, there's another one there?
Yeah,
Oh, okay.
that,
Yeah,
Boy, see, that's,
how is there not a horizontal?
Yeah.
tangent?
that's my question.
so something's
Oh, there's-
goofy, that doesn't seem possible.
Cause the graph on my calculator, it goes up at both
Yeah.
asymptotes.
That's what I would think it would be. I feel like it would be almost symmetrical. Except.
So, okay, so yeah, we had to have made a mistake. We had to have made a mistake here.
Go us.
Did everybody get that? Because this doesn't work, right? If we look at this table, this is an impossible function. How could it go, you tell me, if the function is defined everywhere between -5 and 6, right?
Yeah.
How could this thing possibly go from being up on this, going to positive infinity on this vertical asymptote and positive infinity on this vertical asymptote without ever going through a minimum? Can't do it, right? It can't do it. So there has to be somewhere, welcome to the world of math. This is, somewhere in here, there's a mistake. I think it's with our first derivative.
Oh, no.
I do.
That's why our second derivatives are wrong.
Yeah, I think it's with our first derivative. I think there should have been a 0 in there somewhere. So what did we do wrong? Let's see if we can find it. So we did low, and I wrote down the problem correct, didn't I? That's the first page, right?
Yeah.
Okay. So low d high minus high d low. 2x minus 1, that's good, over low squared. Okay, so then that's going to give us, if I distribute, I'm going to get minus 2x squared
That should be plus 5.
plus 6x
Oh, wait.
plus x, should be plus 7x. That looks right, doesn't it?
Oh, is it plus 3? No, it's not. Never mind.
Did we add these up wrong or something? So we get negative x squared minus 6x.
Wait, do we get negative x, right?
Yeah.
That's right.
What?
Use our calculator and cheat.
Yeah, let's graph this thing and see what it says. Just somebody graph the function.
The graph of the original or the
Yeah,
first derivative?
something's got to be wrong, or maybe our second derivative is wrong.
Well, I mean,
Or it's got to be our second derivative.
it's got.
It's got to
yeah.
be.
No.
Oh, I know what we did.
Oh.
Yeah, I know what we did.
What did we do?
We.
We made up our own math.
Yeah, how did we do this? Yeah, this is wrong. Look, our second derivative, that should have been negative. For one thing, right? That is gonna change stuff, right? Because
What?
look at this. This is,
No,
That's the
that's the bottom.
If you go low, D
I
high,
their program.
minus
okay,
high, D
low.
low.
Oh, no, we're good.
Oh, the
Low,
negative right there.
D,
Right.
D high.
2x is minus right there.
That's supposed to be minus. There it is. Right? That's supposed to be that's it. That's the mistake. That's the mistake. Oh my goodness. Yeah. Okay, I can't, honestly, I can't tell you how many times in college I did a lot more math than that. I mean, like 10 times that much math, and then you're just like,
So how are we expected to do this on a test if we can't even
Do it
class?
together in class.
In two
That's
class
fine.
periods.
take the first Yes.
This was-
I'm down
this
with
one
that.
question-
Partner test.
well, so, no,
This
but it's,
one question
no, I get it.
per
It's,
period.
on a test like this, I mean, I'm not gonna make it, I'm not a big fan of time pressure tests. I don't think in math, they really do a lot of good. There's not a lot of correlation that shows if you can do calculus fast, it means you're a better calculus student. So I'm willing to give you like fewer problems on this, and I'm gonna make them not super difficult. Like, I'm gonna make them work out, so, I mean, this one probably should have worked out too.
Probably.
It probably should have. And remember, on the paper and pencil tests, if you make a little mistake like that, but you do everything right, you're probably getting like 19 out of 20 on the problem anyway, right? It's the process I'm interested in more than,
They can find
The
the
answer,
negative
right.
that you left out.
so I feel your pain, trust me, I've been there.
I'm sorry. I'm not gonna go back.
So what does this do? Let's see how this fixes things when we make this correction. Is that our only mistake? Let's make sure.
I think so.
I believe so.
High, D,
The
low
mistake is
looks good. Yeah, okay.
That's the shortest thing.
So,
Add the negative. Just add the
time to do
negative.
some, well, actually, is there a place where I could,
Just add the negative right
You need to add the negative in the
yeah, so that's gonna be, everything here is just gonna change sign, isn't it, on
And
this,
then in the next
on this
step,
part?
the
Well,
next,
not,
no, then the next
we,
page.
we did the combining like terms on the next page.
Yeah. So if you just put the negative there, go to the next page,
Yeah, go, the next
add
page,
the negative there.
Oh, next page, yeah, I see what
Yeah,
you're saying, we didn't,
yeah.
right, right.
next page,
So then,
okay. And so then
The
the
negative.
negative,
here, if that was supposed to be a negative, right?
uh-huh,
Then here's where they should have changed. So this should have been, that's gonna make that term positive, right?
Yeah.
Yes.
yes,
And it's gonna make that term negative,
yep,
okay? Which is only gonna change, doesn't change that much. So then it's gonna change this stuff here, isn't it? So we gotta go down,
so that would just be X cubed.
I'm just gonna do all this again, just to make sure. So that's gonna become an x cubed. We're gonna get 4x squared minus 13x squared. So that's gonna be minus 9x squared. We're gonna get 70, see, I think this might, no, it's not. So I'm gonna get, what did we say that was? 27 and 72 is 99. And then minus 123. Okay, that's very different. Okay, so this is,
Yeah, that changes it.
that changes.
Garbo.
Do you even know what Brendan is?
Yeah.
Do you know?
Okay, back to the drawing board. So that's our second derivative. So let's find the zeros of that.
First time I heard that song was in Chauncey's truck. First time I heard that song was in Chauncey's truck.
Yeah.
Colt Ford.
You wanna go to the park after that?
Smoking a cowboy.
Dude, one of the coaches.
I went
that
to
was
Hawaii,
already in the
man.
hallway. These kids are like 7 or 8. And she started just like cursing at him, screaming at him, crying out of the bathroom. It's like, oh jeez. Yeah.
Wait,
The coach.
was it this hallway?
No, it was Ignite, so it was top floor.
Yeah.
Yeah, that coach that's got all the tattoos and everything. She's like, you're asking the first class and everything. This kid's like 7.
That's Dan's team right there.
Okay, so what do you know? We get we only get 1 0 of the second derivative. That's what we need.
That's
Much
what
better.
we need.
Much better.
Wait, and then he just, and I'm saying, oh, it is fun, you just don't tell it like, you know? And I was saying that, like,
Sounds like
Dan's
that.
moms are
Did you say you're not
Yeah,
gonna
you
get
guys
TV?
Yeah, I'm not gonna.
That, Dan, I didn't mention the fact that Dan's moms are crazy.
I didn't have any issues.
Because you
surprisingly.
only have one team.
Yeah, but I had the radio, they tried to make that an entire whole day.
One's like 3.
There was only one team
We
in
got a
this hallway.
streamer.
There was only one team in this hallway.
Yeah, but I also read the line. That,
True.
I was trying to tell people sometimes.
Because that's where all the on my fashion was in the line. Yeah.
The cheats if we got a screamer just to sick the coach down the first level.
That messes up our whole thing. We have to,
One time.
we'll fix that.
No, one time Libby literally
It's
said, we were screwing things up, and she literally said, either I'm gonna slit my wrist or yours, or I'm gonna slit your wrist or mine. And we're just like, Debbie.
That's a little much.
Berta.
And that
You
was
throw it to
her
guy
this
before.
year.